So what we're going to talk about now is how we can build the Shiny dashboard with R. So Shiny is actually a package within R. It's not just the word because it's going to look shiny, but it's also going to look shiny. So I guess it's a good name. So we had that experiment running in the background, right, with the random forest kind of grid search thing. Those results are being saved to S3 as we speak. And we're going to build a dashboard now that can read that data from S3 and then kind of display the stuff, quote unquote, live. So we'll check that out. So, okay, I know I did this in the beginning of the tutorial, but who's left in the room that actually knows R and uses R pretty familiar? Okay, good. So about half the room, maybe even more than half. But if you haven't used R before, here's just a couple steps. The R that we're going to do is all going to be on our computer, and then we're going to deploy a dashboard to a different service. So we're not going to be using Amazon for this. The only Amazon piece we're going to be doing is grabbing data from S3 and then putting it on our laptop or this other service. So to get R working on your laptop, you want to install R itself, so programming language, and then RStudio, which is the IDE for R. And the packages that we're going to use, actually, it's easy now because there's the tidyverse, which is a collection of packages that make processing data and doing a bunch of stuff with data in R like just really easy. It's actually a group of packages, so it's not one single package, but if you install the tidyverse package, it'll install all of the packages that you need. So like dplyr, ggplot, tidyr, forcats, a whole bunch of other packages that you're going to need. We're only going to use a handful of them. So the stuff that we're going to be doing isn't going to be super heavy. It's just download a CSV, process it a little bit, and then make a graph. And then the last piece that we need is this AWS.S3 package. And there's this group called CloudyR. I know it's hard to see, but CloudyR. They have basically a whole bunch of different packages for interfacing with any different cloud. So it's not just Amazon, but they have all kinds of packages where you actually can launch EC2 instances from R. So if you really like R, you can just do it all from there. You can do EC2, you can do the IAM, you can do Google Cloud, you can do Azure, you can do anything that you need to with cloud with those CloudyR packages. But the one that we need for right now is this AWS.S3 package. And so what we'll do is we'll create an R notebook to do a couple things locally first. And then we're going to create a dashboard and then deploy that dashboard so anybody in the world can see it. And to deploy the dashboard so anybody in the world can see it, is this website called shinyapps.io. And it's a service that's provided actually by RStudio, the company. And there's a free tier, which is nice. But what it does is you can just, from RStudio, from the IDE that you're developing on your computer, you can just click a button and say publish, and it'll publish it to shinyapps.io. So you don't have to manage any servers, you don't have to manage any of that stuff. All you have to do is you pay per usage. So the free version comes with 5 apps and 25 active hours. So essentially what our Shiny Apps does is if somebody's hitting your dashboard, it'll just count how often your dashboard is up. So if it's just for personal use, I've never run into any issues. And then if you need it, there's a different levels. There's more tiers beyond that starter, but if you end up using a bunch of different Shiny apps, it can be really useful to have this, and you don't have to manage the servers. I think eventually if you're going to have like 30 Shiny apps, you can just manage your own server, but this is really good just to get started, and then you don't have to do anything. So there's no real Amazon involved here besides the S3 part. So let's do it. Let's dive in. Okay, so we're going to assume that RStudio is already installed and that you have those packages needed installed. So let me close these. I'm going to open this guy. This is just a boilerplate R notebook that I created. Let me go ahead and clear my session too, because there we go. Just want it fresh. Okay. So like I said, the R code that we're going to be doing here is not going to be super crazy. I just want to be able to show you how to grab something from S3 and then display a graph. So if you don't have these two packages installed, you're going to need to run these two commands. It's just install tidyverse, which actually will take a couple minutes because it's not just installing one package, it's installing a whole bunch of packages. And then we'll need the AWS.S3 package. But I already have those on my computer. So we can just launch these.
So why do you need a tidyverse?
Tidyverse, actually, let me just show you. So tidyverse is a family of R packages, which let you do a bunch of stuff with R. So R has a little bit of a larger package universe than Python does, I think. Like Python has pandas. You do all your data with pandas, right? But with R was built to be a data frame language from the beginning. So then there's a bunch of packages on top of it that make it easier to use R. And so what the tidyverse is a collection of core packages that you use. So actually, if you look at my code right now on GitHub, I'm actually loading each of these libraries individually. That's because before I started using the tidyverse package. So it's just a wrapper that makes it easy. It loads all the packages for you. But what we're actually going to be using today is readr, which will let us read the CSVs. We're going to be using dplyr to do some manipulations, just some filtering, group bys, and so on. And then ggplot for the plotting. And I think that's pretty much it as far as tidyverse. But we'll go ahead and load these. If you're not familiar with RStudio or the notebooks, you can create a new R notebook here. It's kind of the same idea as a Jupyter notebook, but it's a little bit different. It's not like a web thing and it's in here, but I can run the whole cell if I say that. So, and then it spits out the output right here. So this is just some warnings. We can clear that. But it's okay. So now I have my packages loaded. What's nice about RStudio and R is that you have this help pane, right, where you can actually just put a question mark in front of any method, and then it'll tell you what it does. You can actually do that in Jupyter too, but R is nice. So what we need to do is remember we have my file here on S3. So this S3 RF trees results.csv. Actually, we can check on our notebook, see how it's doing. I think it finished. Yeah. All right. It finished, took about 20 minutes to run the grid search from 3 trees all the way to 100 trees. So what we want to do is we're essentially going to take this file directly and we're going to load it into R directly. So what I could do is do this copy command and then open the CSV locally. But because this is going to be in a dashboard that I'm deploying somewhere, and it's just easier, it's cleaner if you just download your file directly from S3. If there's files on S3, you don't really need to stage it anywhere. You just can grab it and use it. So inside of this aws.s3 package, there's a function called getObject. And so if we look at the help for this, what getObject does is you give it an object key, and then you give it a bucket. And then it grabs the object. But it's not necessarily a file, right? It's essentially like a string buffer again. So you know how we wrote the string buffer directly from Python into S3? Now when we grab it from S3, it's still a string buffer. So we have to do a read CSV command after that. So let me just show you. So if I just say T is get object, and I said it was RF trees, what was it? Oops. It's RF trees results.csv. Oh, and then bucket equals, let's close this. Bucket equals, right? If I run that, this object T is just this raw vector of a bunch of weirds, essentially binary. So what we can do, the same way that we used pandas to CSV, except with a string buffer, we're going to use the read CSV with this buffer. So I'm going to say results equals read CSV like this. So I got the object, it's this blob from S3. Now I'm going to use read CSV to read it. Read CSV you would use with a file name, but it works the same way. So now I have my data frame. Same thing that we saw before. So now I have number of trees all the way up to 100. I have essentially what I care about is my test accuracy and my test balance accuracy. And so we see it goes up a little bit as it goes on. So this is our data frame we're working with. Very small data. I'm going to clean this up and make it nicer. So essentially what you can do from here is you say results is this, and then we can use our pipe operator straight into the read CSV, just like that. So R is nice. I really like this pipe operator with R because you can just chain a bunch of series of commands instead of growing larger and larger with parentheses or variables. So that command is just a cleaner way to do it. it does the same thing. Okay, so now we have our data frame, and we have these columns. So let's look at the columns. This is all the stuff we have. So I'm just gonna make like, oh, let's look at the columns a bit though. Let's do a summary. So we'll do summary results. So we can see here that the number of trees goes from 3 to 100. And then our accuracy goes from 66% to 72%. And our balance accuracy goes from 75 to about 80. So just, it's always good practice to look at your data anytime you're grabbing it from somewhere. Okay, now we're going to...
Balance accuracy?
I'm sorry?
What was the balance accuracy?
Oh, here, 75 to 80%.
No,
What is it?
Yeah.
Oh, okay, so the balance accuracy is basically an average of the accuracies of each individual class.
Oh,
So we have 10 classes, like you just got one versus all thing, and then you average them.
you mean the term folds in the cross-validation?
No, our class has 10 labels. Yeah. So it'll say for radiologist, what's my accuracy for radiologist, then what's my accuracy for this, and then it averages it. So it's much better when you have imbalanced data or multi-class, because this accuracy is just dependent on how many classes you have,
Yeah.
right? Okay, so now we're going to use ggplot. So we'll do ggplot with our data. And we'll say the x-axis. So what I'm essentially creating now is like a lift curve, right, to see how many, as we add more trees, how well does our model do. So our x-axis is just going to be the number of trees. So we'll say x-axis is n trees. And then for now, we'll just say the test accuracy, because that's kind of what we'll look at. So we'll say the test accuracy for our y. And I'll do a scatter plot for now. So geom point. Boom. So here we go. So now we have our graph. So we can see now those numbers, the behavior of the plot as it goes. So looks like we tend to level off around 50, and then as it goes higher, who knows, it probably just kind of converges a bit there. But I'm kind of a perfectionist, so I want to make this graph a little bit prettier. Rather than just the dots is good because we can see what the variability is between each fold, right? So since I did 3-fold cross-validation, there's 3 points. But I want to see the mean, right? So I'm just going to do a stat summary. And we'll say the y function is going to be the mean. And we want a line, and I want a dotted line. Oops. I don't need that plus. Okay, so same thing. Now we add a dotted line with the mean at each point. Just to get a little cleaner, I like, especially because we're going to put this on a dashboard, we want to make it nice and professional and clean looking. And it could get it publication ready too, which is nice. Let me set the labels. So the X label is the number of trees. The Y is accuracy. And we'll use a theme just to make it prettier. Okay, so there's our final graph. And what we're going to do after this is we're going to take this graph, put it in a dashboard so it can be used in real life. Besides this, maybe if we want to analyze the data, we actually do still want to see like the actual raw numbers. So we'll do some dplyr, like very, very minimal dplyr to get that. Because right now, this data frame has 3 entries for each number of trees. So I'm just going to take the average of that so we can have like a nice clean table to show us everything. So if we say group by n trees, and this is handy. So normally you would do the summarize function and then you would say which aggregations you want to do. But actually if you do summarize all, and I can say do these functions, and it's actually going to execute the mean on every single other column in this data frame. So now this is going to give me entries, the average of the fit time, the average of the score time, the average of the test accuracy, so on and so forth. So I could have done, like, if I wanted average and standard deviation, I could put those both in. So now I have the time mean, and then I would get the time standard deviation, so on. So of course you can change that as you need to. But for now, I'm just going to keep this on the mean. And that's it for this notebook. So it's really simple. We can preview the notebook now. So now we get a graph of our results, and then we get Oh, did the table? Oh, I deleted the table. There. And then we get a table right here. So if you think about this, and the way that I was doing this originally with my experiments is, let's say this experiment was still running. The CSV file would be being updated in S3 kind of as we're working on it. So what I would do is I would just open my computer and like launch this notebook and click and run the command again and again every time I wanted to see an update. So I'm like, well, that's kind of annoying because you got to launch the code and whatever, but also I wanted to share the results with my professor. So I wanted to be able to say like, here's my results. And instead of having to update him every time a new model finished and send a new email with a new PDF or a new HTML file, that's why I went ahead and created the dashboard, because now I can give him a link to the dashboard. He can just see how the results are happening live. And if I say something worked, I can change it really fast before he gets to see it. So that's that. Any questions on the R or the data before I show you how to do the dashboard part?
Can you run your R notebook similar to what, not right now, but I'm saying we can run it on EC2 similar to what we did with the Jupyter notebook?
Yeah, so Jupyter supports R. So you could do the R in Jupyter. Or actually the best thing that I like is you could do RStudio Server.
That's what I was
Yeah, so RStudio has this exact interface but on a web interface. And I'm sure there's an AMI, or I'm sure RStudio has really easy instructions for you to set up RStudio on Amazon. So let's say you don't even want to do the Python and you want an R machine with 500 gigs of RAM, you could totally do that. I've done that. We've done that at our office
So
before.
basically, but you can run RStudio on your local machine and it will run.
No, you'd be using the RStudio that's hosted on the EC2.
Oh, okay, gotcha.
Yeah. There's a question back there? Sure. Yep.
So for this R table, you're getting the data from your S3.
Yes.
So does that mean that you are taking the data out and that costs, like, that's the expensive one?
Correct.
Okay.
But in this case, it's just my results CSV file, so it's really tiny.
Okay.
So it's not like real data.
Yeah.
Yeah, but you technically are paying for that.
Yeah. It's 9 cents a gigabyte and plus.
Yeah, it's way like, I mean, this file is going to be kilobytes,
Yeah.
you know. Mhm. But yeah, technically every time I hit that and it's grabbing from S3, you're paying for that.
So that's why you don't want to update it every, like, very often.
Yeah, and really, if it's just you, you don't want 10,000 people hitting your dashboard. That's really the biggest thing. Like you refreshing, even if the dashboard's on 24 hours and refreshing a bunch, with this size of file, it's not going to matter too much. Yep.
So what's available within R to do SVM, random forest, logistic regression, and so on?
There is.
Stay there.
So its package ecosystem is a bit more fragmented than Python. So Python, it's like go to scikit-learn, all your machine learning is there. But there's a new package called, anybody know? There's Carrot, but they made a new one. So Max Kuhn actually worked with Hadley on making another one. Was it Tidy Models, maybe? I think it is Tidy Models. Yeah. So yeah, so it's Tidy Models. It's kind of like a follow-on to Carrot. Because Carrot, it kind of unified some APIs, but it was still kind of messy, and you kind of know what each package you were doing with. But Tidy Models basically gives you, and it fits in the tidyverse, so it gives you that same exact syntax for everything. So it's essentially like scikit-learn now on R. So that's really exciting. That's fairly new. And there's a lot of just random, just talking about is R is starting to support a lot of Python as well. So you can do Python from within RStudio, and just within the last couple of weeks, they've been launching a lot of that stuff. So it's really nice. So I've done that myself actually, where if my data is small enough to fit in R, data processing on R and visualization is just like for me way better than Python. But sometimes I needed to run like an intensive processing routine, and then you can just call a Python function, and it'll actually use your R data frame, pass it to the Python function. You can do stuff there, and then it'll go straight back. And that's really nice.
So you've moved into the R world just because of the ability to refresh and display in interesting ways. Is that, or you want us to see R? I'm not clear why you've done this.
Yeah, so I think R, at least for me, my experience, I like the way you present and visualize data with R, and then all the statistical stuff. So I had a paper a couple days ago where I trained a bunch of machine learning models, but then I had to fit like a mathematical curve. And that curve fitting I did with R. Just from my own experience, I found that the visualization, first of all, with ggplot is just way better than matplotlib. and the whole ecosystem about how I can create this notebook and it creates this HTML file and that kind of stuff was just nice with R. And then the Shiny dashboard. There is a package called Dash in Python. It's made by Plotly, which is another plotting package in Python. And so I think Plotly is a lot easier to use than matplotlib. And then Dash is kind of a similar correspondent from Shiny into Python. So this is just because I've experienced, this is the way I've done things. You could stay in Python if you want, or you can stay in R if you want. It's really just up to you. All right, so let's do the Shiny part. We've got about 20 minutes. Shouldn't be too bad. And if anything, I can just skip to the end. So when you want to create a new Shiny app, you go into here, File, New File, Shiny Web App. So it's a little bit different because it gives you this kind of, scaffolding that you have where your code is set up. So what Shiny does is it creates a web app and you don't really have to know HTML, but if you know HTML, it helps because it uses some of the same directives. Like it'll do H1, H2, that kind of stuff. So we'll make a new app. I already have one already a bit, but let me put it in, just put it in my desktop. No, I need to put it somewhere here. I'll do it right here. And we'll call it Shiny Test. Okay, so the concept of Shiny, and I'm not going to be able to get into it all completely, like you could spend a whole 4 hours just talking about Shiny. But the concept is that there's a UI component of the code, and then there's a server component of the code. So the server component, it's what's doing all the data processing, it's flipping the tables, it's generating the UI elements, and then the UI component is basically laying out your web page, saying, okay, I'm going to put a title here, I'm going to put a sidebar here, I'm going to put a table here. You could have multiple files if you have a really big web app, but in this case, we're going to put it in the same file. And I'm actually going to take a little bit of other boilerplate code. But if you look here, and you go to, RStudio has fantastic documentation as well. If you go up here, you can see all the cool things that you can do with Shiny. It's really, really powerful. But what's nice is I'm just going to be copying code from my notebook and dumping it here into Shiny and then connecting up some of the Shiny portions. So essentially, you can see here that there's a UI variable, and that has the UI definition. So this is Shiny's boilerplate. We can actually run it right now. So this boilerplate thing is just a graph, and then you can change this little widget, and it'll update the number of bins on the histogram. So if you see that in the code, we have the title panel here, which gives you this title, and we have a sidebar. So it's because it's responsive. So if I make this big enough, it becomes a sidebar. And then we have a slider input thing that says, this is our slider input, and then our output saying on the main panel, you're going to show this graph. So that's the UI component. That's saying, here's the placeholders for all the things that we're doing. And then the server logic actually does the kind of R processing. So it's going to say, generate some data, and then do a histogram. And then you just say Shiny app with the UI in the server. So I'm actually going to take one of my files already, and I'm going to copy this into here. So, excuse me. So because I have S3 set up on my computer, and actually that's a really important point, you have to configure S3 locally, your credentials. So I'll show you that after this. I know it's kind of backwards. But you saw that the S3 kind of just magically worked when I did this get bucket thing. That's because my laptop is already configured with my user, because it's me as a human interacting with S3. I have a user account. Essentially, it's an access key and then a secret key. And I have that installed in a special place on my computer where any Amazon code running on my computer knows to grab those credentials. So this works just fine on my laptop. But if I want to deploy this somewhere, those credentials don't live in the place that it's being deployed in. So you actually have to set up environment variables. So you have to create this R environ file and then put these things in it. Of course, I'm not going to show you mine because those are my credentials. But I have that file already, and I'm just going to copy it over. So just kind of ignore this, what I'm doing right now. So I'm going to copy. I have already a complete notebook here that I was using as a backup. So I have this R environment file, and I'm just going to copy it over into my Shiny test folder. So I can't show you what that looks like, of course, but essentially it's just this. And then from the Amazon console, you would have at one point in time downloaded a CSV with your credentials, and then you got to save that in a safe place. It's different than your PEM file. Your PEM file is what lets you SSH onto the computers, but this is essentially your username and password for Amazon. So I have now an R environment file in this path, and it's going to let me deploy this into the Shiny apps. But obviously, before we get there, we need to build the app locally. So the first thing that I did is I copied over my data frame code. And so this is just at the top. Before I even get to the UI or I get to the server components, I'm just grabbing my CSV. So basically, every time I refresh the page in Shiny, it's going to rerun this code. Whereas in these other components, as I interact with the app, it's going to do things. And I actually am running pretty short on time, so I'm going to have to go pretty quickly, but we can talk later. You can watch the video again after this. So if we just look at the app that I have right now, it's just an empty app. So I just have an app that says Medicare ML results. So the first thing I'm going to do, so the first thing I already have set up is I have an plot output section in my UI saying in my main panel, output whatever this results plot object is. So the way that you create those objects to pass to the UI is your server function has this output variable, essentially a list. So you add a new entry to the list for results plot using this render plot function. So there's render plot, there's render table, there's render all kinds of other things. But in this case, we're just going to render a plot and we're going to render a table. So what I can do is just take my plotting code directly from my other notebook. It's going to work just fine. So I'm just going to grab this. Close that. I'm going to put it right here. So what this does now, it's going to generate a ggplot graph that's going to go into this results plot object, and now this is going to show it. So I'm going to run this. So this is running locally. I'm not deploying this right now. Let me just go ahead and save. So now I have my graph. Boom. So what that did is it grabbed the file from S3, it created my graph. So now I want to put a couple little nice widgets for me to interact with this. So the first thing I'm going to do is, well, maybe I want to zoom in on a particular section. I want to see just from 75 to 100. So I'll put in a widget, a filter, a slider, that's going to let me determine which part of the graph I'm showing. So with that, I'll start with my UI part. Let me kill this first. And I'm going to say slider input. So, and then if you do the question mark thing again, you'll be able to see kind of, you'll be able to see some stuff, documentation about it. I'm running out of time, so I'm just going to run through this pretty quick. So I'm going to say slider input, and you have to give it a name. So that's my name that I'm going to be using, referring to throughout the app. And then I give it a title. So you can see, you can watch me do it here. So input ID, label, min, max, x-axis, limits. I'm going to say, in this case, I know my min and max because I just decided this 1 to 100, but you can actually dynamically compute your min and max based on the data. I don't have time to show you that now. On my GitHub, I actually have stuff that does that. Okay, so now I created this new slider. If I run this, it's going to show up, but it's not going to do anything. So now I have this slider I can do things with. See that? Okay, but now what I have to do is I have to make the value of this slider as an input into this method that's generating my graph. So as I change the slider, this graph is going to render again. So the way that works is you have this input variable. So this input is going to be a list that is based off of these input IDs that you give. So what I'm going to do is I'm going to actually filter my data frame. What I could do is I could do like a scale x continuous and put limits on it, but then it wouldn't really resize the y-axis accordingly. So I'm just going to do a filtered one. All right, so I'm going to say filtered is results, filter where n trees, because I know n trees is my x-axis, and then this is where the input thing comes in, is x limits, because that matches my input ID. So what this does is it gives a vector. The first entry is your min, the second entry is your max. So I can just say, make sure it's greater than my min, and make sure it's less than my max. Okay, And then I'll take this now and put that in the ggplot. I could pipe it if I wanted to, but it's cleaner this way. So now, changing that widget is actually going to affect how my graph looks. Boom. So nice, really nice, quick stuff. Once you get used to Shiny, it's a little bit of a learning curve to figure out what all these components mean and how to do all this stuff. But it's a lot of just trial and error, changing things and reading documentation. But now I have this nice kind of responsive graph with some filters. Next thing I'm going to do is, well, maybe I don't want to see the accuracy as my y-axis. Maybe I want to see some of my other metrics. So we're going to add a drop down for us to determine what the y-axis is going to be. So now I'll do another input, which is going to be a select input. And I'll say plot y. And then I'm just going to call that y for the name. And then you could explicitly set the choices. But in this case, I'm going to say I could be running any experiment. I don't know what all of my potential options are for my y-axis. So what you do in the UI section is you say the choices equals null. And then in the server section, you're going to dynamically figure out and insert the choices back into the UI object. So the way you do that is you create this kind of observe. So this is now saying render this plot into this thing. Now I need like a new operation that's saying just observe this and wait for this event. So essentially what this is doing is just run this code every so often. So I'm going to say update select input. Session is one of my arguments here. If you start with a boilerplate Shiny app, this session argument is not going to be there, but you can just type it in and then it'll work. So I'm going to say session, and then I'm going to say plot y is the input ID for my thing. I'm going to say my choices now essentially is going to be my column names of my data frame. So if I put a new data frame on S3 with more columns, it's going to dynamically update that choices list. So I'll just say call names results. And it's not doing anything now, but now we're going to see the placeholder come in. Oh, something died. Results with an S. Okay, so now we have this drop down and it's filled with all of our column names. We change it, it doesn't do anything, right? Because we didn't make it do anything yet. So now we're going to go back into the server and we're going to use the UI component now to do some filtering. So in this case, for the plot, we hard-coded the y-axis to be the accuracy. So what we want to do now is we want to say, take our input object, the same way we did this x limits, right? This x limits here. We want to grab our plot y input object. So we'll say plot y.
So is the server your computer? Like, so if you had something on like the web, and somebody was going to look at it, like a professor, then and he did the dialing thing, then that would, be the server called your computer.
Not right now. We're gonna deploy it somewhere. This is just me developing
Okay, so
locally.
it's on your local.
Yeah, we're going to deploy it in just a second. So now I have to change this to be a variable depending on what I select. But this is just some weirdness about ggplot. ggplot expects, doesn't like strings in here. So to explicitly say use strings, you have to say AES string, and then put this hard-coded one as a string, and then this one comes through as a string. I don't have time to explain why that is, but just do it, and then it works. So now we're going to run the app, and now we get these filters. So there we go. So now we can click this, and the graph changes. If you wanted to, you could set a default also to say default to the test accuracy. And then, of course, if we do entries, it's going to be a straight line. We can zoom in and out, and now it's nice. Now we have this responsive kind of web app. The last thing I want to show you is, let's say we wanted to add the table also. So we want the graph, but when we see the patterns in the graph, we actually want to dive in and see what the actual numbers are. So we're going to add a tabbed view. So we're going to create a tab right here where we can flip back and forth between the graph and the table, and it's going to keep the same filters on it. So this requires a little bit of work on the UI side. So I have to change up a little bit of what I'm doing. But now, inside of the main panel, we're going to have more content here. So we've been operating in the sidebar mostly, but now what we're going to do is create a tab set panel. And then within the tab set panel, we're going to have tabs in there. So now we're going to have a tab panel, and each tab has a name. So I'm going to call this plot, and then my actual placeholder is this plot output. I'm going to do another tab panel, and I'm going to call that one table, and then I'm going to do a table output. This is going to be new. Table output, and I'm going to call it results table. Okay? So this is another object it's expecting inside of the server. So in the server, instead of this render plot, we're going to do a render table. So I'm going to say output results table equals render table. And because I want it to match the filters that I'm doing, I'm just going to go ahead and copy this code. I could create another method and just read from that, but I'm being lazy. And then I'm going to grab our table code that we have before. And then that's it. And then it's going to take this last thing, and it's going to know that it's a table, and then it's going to render it through. So now we have a little tab view here, and we can switch back and forth between the plot and the table. Actually, if you wanted to, this shows the full table. If you wanted to use the input for the y, you could just say only show me this y that I'm looking at. But then if I change this, the table is now going to update to only show me those things. It should. Oh, it didn't because I didn't put the inputs in, right? So I have to, because I didn't use filtered here. So I use filtered there. There you go. And then now if I go to my table here, and I change the slider, the table's going to update. So I know I had to breeze through that because we were running out of time, but I'll have this code up on the GitHub, and we can chat more about it if you're interested in Shiny. Now what we really want to do, putting everything all together from this whole 4 hours that we've been together, we want to deploy this. So now we can deploy this app, and now we can monitor our machine learning experiment in real time. So it's super easy. All you got to do is click this little button up here, and you just say publish. So there's several places where you can publish. If I already have my account hooked up, but if you didn't have an account with shinyapps.io, you would just click create new account. You would go on their website, create an account. You can log in with like a Google account, so it's super easy. And then you log in, and then you just click publish. So you notice the two files that it's publishing is my app.r and then my R environ. That's how it's going to know my AWS credentials to be able to work. I actually had to search a lot on the internet to get the AWS part working. I didn't know how you were able to inject kind of variables into a Shiny app with shinyapps.io. So if that's one thing that you remember from this talk, just use your .r environ file to put your credentials in there. So this is actually going to be a brand new app. So I'm going to log into my Shiny Apps thing right now, and I can show you that I have 2 applications that are online right now, but it's going to be a brand new one. So I'm going to say publish. And this is going to take a couple minutes. So if anybody has any questions, we can go through some questions now while it deploys.
So the .r environment variable, that's holding on to your AWS, specifically the S3 keys.
Correct.
To allow you to get it.
Correct. And so the file goes into the Shiny Apps server. So of course, anybody from the outside doesn't know what that file is, but it is somewhere in the Shiny Apps cloud, because it is a cloud, right? But that's letting you get access to your. So like if your S3 bucket had like sensitive data and you don't want RStudio, technically they have access to it. I'm sure they wouldn't access it. You'd have to figure out that kind of stuff. But for this, it's just my toy data.
And people wouldn't be able to download that R environment variable and use it.
Correct, they would not. This is once the web UI comes out, it's a read-only kind of web UI. Yeah.
How would so once you deploy this, the rshine.io website will automatically retrieve the file from S3. Is that a pull, or does S3 push it to the app?
It's a pull.
So
And that would be your output data transfer cost as well. It would trigger that.
Configure how often it should pull in the app itself.
Yes, so you can do that. So if we go into the Shiny Apps, and this is one of my older apps. It's still working on deploying my other one. You can go in here, and I believe you can set some settings.
Will you be able to detect if there hasn't been any change?
Yeah, you'd have to build that into your app. Because you could do like a checksum or something on the S3 file and then detect if it's changed or not. If you want to limit the number of pulls that it does, that would be a good option actually. Yeah. But then you would have to cache the file somewhere within, and that would have to all be in your R app. I don't think shinyapps.io does any of that. Yeah.
I think you can buy the, instead of deploying to rshiny.io, you could get your own RStudio server.
Yep.
Deploy it on your own.
You could. And if you really wanted to, you could launch an EC2 instance and just run the Shiny app from the command line there, and it would deploy it as well. So here it is. So now this is live on the internet. Anybody can go to this URL and see my Shiny app. So, and if you refresh it a bunch of times, you'll start charging me money on S3.
I know, like, for example, AWS has this new service called, it's been around for a while, QuickSight, for visualizations. I don't know if you explore that.
I haven't. I'll check that out. I haven't heard of that one. I'll check it out. I know that you can do like static websites with S3. So if you put an HTML file in S3, it actually turns into a website. But I haven't checked that out.
If you design this kind of a web GUI, you can only use R, you can only use Python.
Well, since this is, yeah, this one would just be R, the Shiny. If you really wanted to, you could run some system command to call something else with Python right now. Python does. If you look up dash, a package called dash, so we'll look up dash by Plotly. It's pretty much the same exact thing. It's the same thing. Crazy. Actually, I guess they do R too, but obviously the API is different, but it's the same concept. I don't know. I don't know if they have a free kind of hosting thing like Shiny Apps has, but there's other ones too. These aren't the only two options. There's other stuff as well. Let me run through a couple more slides just to finish off the talk, and then we'll be done. So this was the heavy experimentation part that I'm just going to fly through. There's multiple different ways to access AWS. The web console, which we went through. I did a little bit from the terminal, and then I showed you a bit of the Python 3 or the Boto 3 Python API. But the key thing is, even if you were wanted to do just the Shiny part, you have to install the AWS CLI on your computer, so that way you can configure your credentials. Or you could just set your credentials in your R environment file, either way. But this terminal part will let you actually do those AWS commands that I showed you from your laptop. This is a bunch of other random things to do. Actually, what I'll end up doing is I gave another talk at a meetup about a year and a half ago where I kind of went through this framework. I can put a link to that in here so that way you can go through it. But essentially what I did is I had a bunch of Python code on my laptop that would launch an EC2 instance, and then it would kick off a machine learning experiment on that EC2 instance, which was saving all the files to S3. So that way I didn't have to go into the console. I didn't use any Jupyter notebooks. This was just for like the production kind of thing. So you launch a machine, it runs, and then now it's running on its own, saving files to S3. And that's kind of the working example that I showed you. So this is the GitHub page. I already showed you the link for it before, but this will give you kind of your whole walkthrough. And then this is an example of a real dashboard that I actually sent to my professor. But none of you can get to it because I made it password protected. So it's just a screenshot. This is an actual experiment that I ended up running. I think this particular one I ended up not publishing, but I actually did use this. And that's it. So I know we're out of time and I was a little bit rushed at the end, but if you want to talk to me after the session, we can talk. Like I said, we're going to post the videos, I'll post the slides, I'll post all the code on the conference website. And if you follow me or whatever, you can get stuff a little bit quicker. So thanks for attending.
Thank you.